wondering, is she coming? Is she not? I guess not.
Never seemed to care about it. All right. Nothing that occurred prior to the class will be spoke up in the video. All right. I want to go through and touch base on. So we got omnibus stuff figured out. Want to start thinking about like how do we go through and start teasing out simple effects within these designs. Okay. Again, traditional approach, right, involves looking at those within subjects contrasts using the pooled error term from your mean squared repeated within groups, right, from your overall ANOVA table with this. Okay. The problem is if we go through and do this, what happens is that violations of assumptions start to do unpredictable things. Type 1 error you have for your specific contrast, right? So for all of these, we have evidence for violations of homogeneity or between. Now homogeneity or within looks like it's probably okay. So that's sort of getting at some of that within group stuff. But then we got a violation of sphericity always, and that sort of comes into play. So we've got to be very, very careful with just pulling error terms from our overall ANOVA table and just plugging that in. Okay. So a recommendation that Hal makes, and I think Hal is really smart on this, is talking about falling back onto what we might what we might refer to is a simple effects repeated measure ANOVA. Trend analysis for paired sample tests at each level of the between subjects factor. Okay. But specific approach is going to depend on kind of what you're trying to do and how you're sort of doing this. Okay. When I'm talking about a simple effects repeated measures ANOVA, what it would be is say in our group for our treatment data would say, all right, I'm going to split the file by group. And I'm just going to run a one-way repeated measures ANOVA individually for each one of those groups. Okay. Now, do we need the omnibus test for that? No, we're not interested in that. But if I go through and I do that, what I'm going to do is any of the specific tests that I would go through and run with that takes out that between subjects factor and is just looking at the within stuff. Okay. And so what I'm talking about is simple effects repeated measures ANOVA. It's so with this mixed factorial design in terms of those interactions, again, just separating by group and then just running the within, just a simple one-way repeated measure. And then we sort of we get a little bit sort of looser on some of the restrictions on assumptions and things along those lines. Yeah, right. Also trend analysis, paired sample tests, and we'll talk about some ways to go through and approach this. Yeah. So this is, again, when we're thinking about this, we have to account for and write this down and circle it, okay? When we're working with these repeated measures designs, we're almost always most concerned with the repeated measures effects, okay? The between are fine, but the within is really what we're interested in, okay? This is a mistake people make when they're doing this. It's easy to start falling back on like, well, is this group different than this group? We're kind of wanting to go through and take a look at that, but really what we're interested in looking at is within each individual groups, what are we saying in terms of changing in means and things along those lines, okay? So wanting to think about, as you're going through and approaching this, wanting to think carefully about what's the design, what am I expecting to happen with this, and then how do I best sort of test and pull this out, recognizing that most of the time the thing that's of greatest interest is going to be what's happening within groups as opposed to between groups. Also recognize that you're going to have way, way more power to detect mean differences within groups as opposed to between groups. So you want to be really careful and sort of be aware of that as we're going through and interpreting things. Okay. So options for looking at between effects here. One, we can just use between subjects ANOVA and our independent sample t-test in each one of our repeated measures. Okay. Again, we're talking about this as simple effects ANOVAs, right? I'm going to go through and I'm going to say if I've got 3 groups at each one of my time points, right? What I can do is just break this down and run sort of one-way ANOVA at time 1, a one-way ANOVA at time 2, a one-way ANOVA at time 3, and then just use our sort of standard between subjects stuff to just go through and look at those to start to tease things apart. Okay. Or what I could do is I could go through at each individual time point, set up sort of t-tests or things along those lines. Okay. What we want to do is break this down as to make this a simple problem to say, am I seeing differences across my groups at sort of this time point, this time point, this time point? And then I can just fall back on looking at sort of comparison, contrasts, things along those lines individually across there. Okay. Now, pros of this, just a simple extension of the between subject stuff that we did all last semester. Look at contrast, confidence intervals, effect sizes, things along those lines. The drawback is that we're giving up our degrees of freedom for our full analysis, so we have less power, right? Which sucks. And also, if we have massive violations across the board, we want to start to be really careful about like, oh, I'm just going to pull this term from the overall ANOVA and just run with it, because that starts to get dicey. Okay. Other thing that you can do, if we're really getting in the nuts and bolts and the weeds of things, what we can do is start calculating contrast specific variances and errors based on raw data terms from the overall analysis. This is some real like under the hood business. Okay. What we're doing is we're sort of parceling out some sum of squares stuff to go through and start to pull terms from different components of our omnibus test to build in standard errors and things along those lines. And what we can do then is use degrees of freedom for the overall model. And this gives us a greater power. Drawback is it's computationally intensive. You need to know how to do it. You have to tell people exactly what you did and how you did it. And then also we start to worry about the validity of these tests if we start to have violations of assumptions in our data, which anytime we run a repeated measures ANOVA, we're already having a violation of sphericity. So we already know that's one, right? So we got to be really, really careful with this thing, okay? So as a consequence, we're not going to do this for this class. You have occasion to go through and do this and dive in the middle of the methods textbook and things. Think about like what we're doing in that Bakeman paper, except taking that same type of approach with any contrast or anything you're doing. Like that's kind of what's happening with this. It's a lot. It's more than we need to do because this is oftentimes just easier to go through and do. It's easier to report. We have less concerns about violations of assumptions. And so for our class, this is kind of what we're doing. Know that this exists, but this is what we're probably going to do here. Okay. Questions about this? Okay. So let's jump in and walk through handout for our grouped-based analysis or our ordered means. Okay. So in our omnibus stuff, remember we found evidence for an effect here of session and then session by program. Okay. Session is just saying that my repeated assessments are not identical across evaluation or across time points, which is good to know, but so then remember being modified by program, saying that the pattern of means that we're seeing across repeated assessments is going to differ based on program. Okay. But I really don't know what that looks like until we start getting into specific means. Okay. So if I get down here, always plot this out. Okay. SPSS will give you this. Okay. But also remember that like this here is telling me this plot here assumes that I have differences. This plot is assuming that I have an interaction, right? We have a line here for program 1, program 2, and program 3, all plotted across my repeated assessments. This is a nice way to go through and get sort of kind of a quick and dirty plot from SPSS about what these means are looking for. But Catherine, if I had not found an interaction with this? Would this plot be appropriate? No, because I would see differences. They're not all going to line up on top, but statistically, I'm not finding evidence that there's something different going on across this. So it's sort of misleading, right? So if I were to have just a main effect in my repeated assessment, I would probably maybe look at this to see kind of generally what's going on, but I wouldn't put any stock in this, and certainly wouldn't report this because this wouldn't be the effect that I'm actually looking at, right? Here it is though, right? And so what we can go through, and you'll see here, this is where those E-means or those marginal means are coming in, okay? Want to be careful with these because these are not observed means, but these are a nice way to go through and just kind of look at your data and see kind of what's happening, right? And technically, these are the means that so your model is sort of assuming in terms of teasing things out, okay? So here for our main effective program, we see values going from or excuse me, this is sort of these are my mean differences across program. Okay, so collapsing across time point, here's the average score for program one, collapsing across time point, average score for program two, collapsing across time point, average score or estimated average score for each one of my groups. Now, if you were to go through and actually take the mean across all 4 of your time points and then just have like a mean score there and look at a difference across groups, they're not going to be exactly the same, right? And you'll see here that you're not getting a standard deviation with these because they're estimated. They give you a standard error, which is then going into the calculation of this, right? So you got to be careful with these. What I usually use primarily for is just to kind of see just quick what's going on with this, right? Now, we didn't go through and see evidence of a between groups factor on or a between groups effect on this, which suggests that based on our data, it looks like collapsing across time points, we don't have evidence for differences in overall BDI scores across groups. It probably isn't something that's super interpretable in this anyway, but that's kind of what this is looking at. Okay, people see what's being captured by these estimated means. Okay, then we have our estimated means for session. Okay, this is useful, right? This is this conditional effect of our repeated measure saying that collapsing across groups, mean at time 1, mean at time 2, mean at time 3, mean at time 4. Very clearly, we're seeing sort of large dramatic reductions across intervention or sort of ignoring intervention, ignoring program across the course of intervention. This, okay, so individuals in our inpatient treatment center are showing substantial reductions in BDI from baseline to 6 weeks out. People following that? Okay. Then we get down here. These are our program by session needs. This is what's being captured in this plot. Okay. Now, again, if you were to go through and actually calculate these out, plot these out in Excel or something like that, it's going to look a little bit different because these are estimated means versus the actual sort of observed means. But here, this is what's being captured here. So program 1, baseline 2, 4, 6 weeks. Same thing for program 2. Same thing for program 3. Yep. Catherine, so we know that we've got some differences in the pattern of means across repeated assessments within this set of scores. Are you seeing anything like what just looking at the graph, what would you make of that?
I guess it like kind of looks like programs 1 and 2 scores might be changing a similar pattern, and program 3 might be a little different. Steeper drop off, I guess, of scores for sessions.
So we've got maybe looks like program 3 is maybe sort of in it, so it definitely ends at the lowest point. But it looks like it's pretty parallel to 2. 2 starts out higher and ends up a little bit higher, but I don't know if there's much different going on there. 1 is kind of an in between here. How many William, how many actual pairwise comparisons can we pull out of this? A lot, right? what we could do in terms of simple effects, if we're not even including contrast, like combining these, right? For each group, we could go baseline to 2, baseline to 4, baseline to 6, 2 to 4, 2 to 6, 4 to 6 for each group. That's just our withins. Then at each time point, we go 1, 1, 2, 1, 2, 1, 3, 2, 3 at time point 1, time point 2, time point 3, time point 4. Yowza. That's a ton. That's not even accounting for sort of stuff that we could go through and start combining. So this combination of this and that, right? This starts to become a lot to manage, even just looking at pairwise comparisons. Okay. So what we got to do is come up with a plan to say, like, what's going on. Okay. And a lot of this is going to be based on the design here. Okay. So Katie, you're off the hook on this. Clinical folks, do we need to see what the difference is between week 2 and week 4, or week 2 and week 6, or baseline and week 4? There's just a lot of stuff in here that's probably not necessarily interesting, or that we don't need to go through and pull apart. We can provide means and standard deviations. If someone does want to go through and do that, they certainly can. But for us, it's probably not useful. And honestly, this data set is not really good. Sort of repeated measured ANOVA is really not a good design for this, for the types of things that would be most interesting. A growth curve or a HLM would be a better approach to this, right? But we can still do it, right? So what things might we want to go through and take a look at in trying to break down these data? Jack, what do you think? Like, what might be an interesting test to have there?
Baseline and the last one.
Yeah, baseline and endpoint, right? At each one of these groups, right? Like, just on average, right? If I was going to try and describe this to somebody, what I might think about it is like, for each group, what should people sort of coming into this based on the data that we have? What should they expect in terms of treatment reductions, in terms of point estimates based on our data, and sort of maybe some confidence bounds, right? Effect sizes, things along those lines, right? So I could look at talk about pre, post by group. And how many tests is that, Jack? 3, right? That seems manageable. I like that. And that's something that has a lot of meaning. I can talk about that, right? Charlotte, what else might I want to look at? So we got some within. What about the between stuff? What might be interesting or relevant to think about reporting?
I mean, if you want to just look at like final post-treatment scores across groups.
Okay,
for a
right.
while.
So we got group diffs at post, and how many tests are going to be there?
I mean,
3.
there's 3 groups, yeah.
Yep. Well, so we got three different. We got 1, 2, 1, 3, 2, 3. So we got
Yeah.
three. If we're doing this pairwise, we got 3 tests there. What else, William, might be interesting to sort of test with this from a between standpoint? More as a manipulation check or a validity check. We're looking at between comparisons.
Maybe like between at baseline.
Yeah, right. Are people coming in? Did our randomization work? Are people like generally existing in the same spot when they come in, right? And so here could also see like, and that's a potential for 3 additional tests there, right? So we just took a whole bunch of tests and reduced this down into something that starts to make more sense, right? We've got a series of 3 within and 6 between. Is that the only way we could break this down? No, there's a whole lot of other stuff that you could go through and pull out of that. But I don't know off the top of my head why I would necessarily be interested with that without some other background or sort of things along those lines, right? So again, this starts to become, just because you can do something doesn't mean that you need to do it, right? What we're trying to do with this is sort of reduce things down so that we can tell a story and explain this interaction, right? Remember that the effect that we're trying to tease out here is diffs in pattern of mains across repeated measures by group, right? So we're seeing that sort of across the repeated assessments, we're seeing different patterns of means by treatment condition. And looking at this, this is a little bit tricky. I don't know exactly where that's happening, right? It could be happening, I mean, maybe here in this last part, we're seeing sort of like more reduction. So for one group, I don't know, right? Your strategy for going through and teasing things apart isn't necessarily always going to sort of get at all of where the difference is. We're just trying to do some interpretive stuff at this point, things that make sense. Okay. So I think we've got a good group of tests here that's going to be sort of clinically meaningful, relevant to what we're going to go through and do. What we want to start doing now is start thinking about, like, how do we go through and piece this out? And how do we go through and sort of start thinking about, do we need to control for things? Okay. If I'm going through and I'm thinking about sort of this, probably these withins, probably the hypothesis was that treatment is going to work and be effective, not that it might not be, right? I don't know. So we maybe sort of these three are sort of a priori sort of stuff that we already expected, right? We don't necessarily need, this isn't, does treatment work, probably isn't an exploratory hypothesis. The hypothesis probably that treatment is that we're giving people is going to be effective in reducing symptoms. Okay. So what I might do is say, all right, these ones I'm going to just look at for comparison error rates. And this is a little bit like, do we have any concern that like an alpha correction is going to sort of necessarily change our conclusion on whether or not we're seeing symptom reductions across any of these groups? No, it's not, right? But I don't know. I don't want to go through and sort of necessarily make things harder for myself than I need to. So what I might do is I might say, okay, these three withins, we're just going to test these at per comparison rates, because this is kind of what we were expecting, is that sort of all three of these groups are going to go through and sort of differ. Okay. But here, these are kind of exploratory, right? If we randomize people at the start, should we see differences at the front end? Probably not, but sort of things could pop up, right? And then at the end, this end state functioning, do we see differences there? I don't know, I'm kind of interested in that, right? If I didn't have a clear idea on who is going to be the winner at this, comparisons here are kind of exploratory, okay? So again, when you're looking at these plots for these interactions, you should be thinking about within stuff by group and between stuff at each time point. If you do that, things will start to pop much more quickly in terms of thinking about, like, what should we be doing? How should we go through and tease this apart? Okay. So what we've got then is we've got six exploratory tests that we're going to go through and run, right? If we take 6 times alpha, right, that's the actual error rate that we're looking at. If we just go uncorrected, that's probably unacceptable. So if we don't have strong hypotheses about this, we should probably go through and correct for this, right? Question then becomes, how do we go through and do this? Well, this is where, again, some of that modified Tukey stuff that I had talked about, like before, Becca, I was like, well, you've got, go through and do a modified Tukey. If you set R to 4, that accounts for 6 tests, right? You got 4 times 3 divided by 2 is 6. So you could do a modified Tukey and get sort of a corrected kind of like critical value for this. And if I were to go through and do this, if I take the degrees of freedom from the overall table, that's 222 degrees of freedom. Q critical would be 3.67. I change that over to a T critical, it's going to be 2.60. right? And so I could just go through and run t-tests and just compare them against that, say that's with Tukey correction, Tukey less than 0.05, okay? But then I would also have to explain to my readers like what I actually did. So probably the easier thing for me to do is just Benjamin Hochberg, right? And saying, here I've got 6 tests. I'm just gonna go through and test those there. So if we go through and do this, once we've got that down, running the test is actually pretty easy and straightforward, okay? What I've got here is I just went through and I split by treatment condition. And for each one of these, this is program 1, I'm just running a paired sample test from pre to post, baseline to 6 weeks, okay? Am I interested in the p-value for this? Not really, right? It's just such a huge, massive difference that it doesn't really make that much of a difference. I mean, like I already know what's going to happen, right? But what I can do is leverage SPSS to do things quickly and easily for me. And so what I've got here is an estimate of the mean difference here. Okay. And then I've got a confidence bound around that mean difference. Here's my t-test p-value, I'll report that, so whatever. But then also down here, I can go through and get a calculation of effect sizes, okay? Now, here we have some things that we want to think about carefully. SPSS will give me an effect size, but is this so here we've got, here we've got a Cohen's d and a Hedges correction. Do I need a Hedges correction? No, my sample is plenty big. I don't need a Hedges correction. But I want to go through, and so if I'm going through and doing this, it's giving me Cohen's d, which is using the square root of the average variances across baseline and post-treatment. Is this an okay effect size metric to use? It's fine, right? Some things we want to think about here, right? What might be a better like conceptual effect size to run with this? What do you think, Jack?
The one where there is a baseline.
Yeah, glasses delta, right? I mean, we've got a measure, a really good like measure of baseline functioning and variability around that, right? I don't know how to by hand calculate a confidence bound around delta. I think you maybe get it in SPSS, although you got to make sure that it's using the right thing to go through and do, right? So, I mean, this is fine. It's using the average of variability at sort of both time points, right? So this is probably an okay. I mean, this is basically like a Hedges G, right? It's just using like a pooled variance estimate for within. This is perfectly fine, okay? Delta would be nice from a conceptual standpoint because then I can say relative variability of baseline, I'm seeing a 1.5 standard deviation decrease in symptoms, right? That's kind of a nice thing to do. The only thing that I would be careful about here, right? What did variability in scores look at like at baseline and what did they look like at post-treatment?
Bigger at post-treatment.
Bigger at post-treatment. So if I run if this is using an effect size using the average variance across time points, and I were to calculate glasses delta using only variability at baseline, Catherine, what's glasses delta going to look like relative to what we have here?
Either bigger or smaller.
If I'm dividing that difference by a smaller variability, what's going to happen?
It'll be bigger.
Going to be bigger, okay? And this is where we got to be a little bit careful, right? Because what I could do is I could go through and standardize that using variability at baseline. But at baseline, everybody's coming in to an inpatient setting, so everybody's real worked up and no one's doing well, so you don't have a lot of variation. By the time we get to the end of treatment, some people have gotten better, some people haven't, got much more wide variability. Have to think carefully about what am I trying to do, what am I trying to capture with this? Because if I go through and I calculate delta, I've already got sort of just with average variances, I've got an effect size of, so looking at, so about 1.4 standard deviation reduction in scores. If I were to calculate delta for this, it's going to be even larger, right? And so just wanted to think about the consequences. If I were to do that, what's going to happen, right? So again, delta here is gonna be so the BMI difference, which is negative 15.383 over standard deviation baseline is 9.58. What do I get there?
Negative 1.61 and change.
1.61.
Yeah, about.
So we're getting a noticeably higher effect size from delta relative to sort of what we've got going on. Now, if my variability at baseline is about the same for all of my groups, they're at least comparable, right? So this could be a way to go. Be fine with that. Or maybe I just go with this and say I want to account for variability at push treatment too. I want to make sure that that's brought in, because what I don't want to do is sort of have an overestimation of effect and sort of make my treatment seem like they're doing better than it would, right? I don't know. This is like, if you were to do either one, as long as you gave me a good reason for how you went through and did it, that's fine, right? I just want you thinking very carefully about what am I going through, choosing my standardizer, and not just defaulting to whatever SPSS gave me, okay? People see the considerations we're thinking about with this? Okay, so then because we've just got a split file, here is my effect at time 2. And here's my effect at time 3. Okay, we're seeing large substantial reductions across the board. There's no concern that like I've got a type 1 error. That's very clearly seeing reductions in scores over time, right? But so what we're seeing is the idea is that there's some differences there. And so maybe what I want to do in terms of trying to think about what's going on with this interaction, differences in the pattern of means across repeated measures by groups. This is where I think we fall short in sort of doing things. What standard procedure would just be to say, oh yeah, they're all different, or sort of these are just like sort of this is sort of reduction, 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 and these are the effect sizes, and then just kind of leave it at that. What would be nice if there was a way to kind of pull this together, okay? And this is something I've started to do with papers, and I think it's really slick, is just going through and sort of like, I just hijack that ESCI spreadsheet and just build stuff in there and just do this. I mean, here, what I did based on our results is have a plot for, this is mean reductions, mean differences, program 1, program 2, and program 3. And then here's the same thing, but this is just with effect sizes, okay? This, I think, is a nice way to kind of visualize, if we're just looking at pre to post treatment reductions, like what's happening. Here, I would kind of say, well, it kind of looks like, in terms of just raw reductions, it looks like groups 1 and 2, or programs 2 and 3 might be doing a little bit better than program 1. Still, massive reductions across all 3, but it looks like maybe a little bit of an edge with these 2, which is maybe what's happening, so why we're seeing differences here. A little bit more murky when we get to effect sizes. Here, they're kind of all a little bit spaced out, right? We have considerable overlap, but it looks like here at least the upper bound of my effect for program 1 doesn't overlap or just barely touches program 3, right? So what I might say is, based on sort of this, it looks like maybe what we're seeing is that, just at least in these data, program 3 maybe seems to be the winner. Program 1, the sort of most modest effects, with program 2 kind of existing somewhere in the middle of there. Is that a statistical test of what's gone specifically? I'm not, no, but like I said, my overall sort of omnibus is saying I'm seeing differences across my measures, and this is maybe sort of part of what's contributing to that. Okay. You have to be okay with ambiguity in this, because rarely are you going to get like, oh, this is the clear and obvious answer. like things kind of bounce around a bit with this, okay? But can people see kind of the value of like sort of just visualizing and just looking at point estimates and confidence bounds to kind of think about kind of where things are at? It would be easy to just like pinpoint back, oh, this one's better than this one, better than this one, if you're just looking at point estimates. But if we actually look at the confidence bounds around there, at least in sort of mean reductions, these two are looking pretty much the same. And here, looking reasonably comparable. These two tend to be looking a little bit different. You'll see kind of how we sort of worked through that piece of things. Questions about this? All right. Then what we can do is we can go through and what I did here, given the type of design that we set up, we had talked about setting this up as a Benjamini-Hochberg, okay? So what we've got here is just differences in program 1 versus 2 at intake in 6 weeks, okay? And are we seeing differences across program 1 and 2 at intake in 6 weeks? It looks like you might have evidence for at least at per comparison error rates. Maybe we're seeing a difference at intake across these. We got a difference of about 4 points on the BDI. I don't know if that's a huge deal, but it's like we were like go down and take a look at our effect size. Estimate about the third of a standard deviation, right? So I don't want to dismiss that because I, in other situations, might be super excited about it, but it looks like we may have some difference there at 6 weeks at our final time point. No evidence there. Okay. Then if I go down through and I look at sort of the difference between programs 1 and 3, same thing. Here at nothing that we're seeing at baseline, but maybe some differences at post-treatment across 1 and 3. And remember, those were the two groups that sort of we identified in our plot as sort of kind of being the biggest discrepancy there. Our effect size is again about that 0.3 level, sort of based on how we've calculated it there. And then here is difference between 2 and 3. And again, here, not seeing much of a difference, but down here at sort of post, we should see differences there. Okay. So what we've done here is just gone through and literally just run t-tests at between all possible comparisons at pre and at post. Okay. And based on how we wanted to go through and approach this, what we said is we're going to go through and we're just going to treat all 6 of these as exploratory. We're just going to run Benjamini-Hochberg. And so for Benjamini-Hochberg, we need to go through and get sort of individual comparisons across all of these. Okay. And if we go down through and then set this up in my Benjamini-Hochberg, right? I'm ordering my comparisons from the largest p-value to the smallest p-value. And here's my Benjamini-Hochberg P. And so it looks like, based on what we've got, we had a number of things pop up as sort of interpretable here. But when we go through and we run our Benjamini-Hochberg, it just looks like we've got a difference between 1 and 3 and 2 and 3 at final assessment point. Okay. Everything else kind of doesn't pan out. So here's my S, my Bayes, here's my difference, my confidence bound, my effect size differences here. People seeing how we went through and teased that apart. So are we seeing any differences, at least sort of after our corrected tests at intake? Nothing that's providing us with clear evidence that we have sort of systematic differences at intake, but we are seeing that 2 and 3 and 1 and 3 look to be different, or groups 1 and 2 look to be different than 3 at that final assessment. Yeah.
Well, why is 2 not significant?
Well, because our p-value is 1.75 and our Benjamini-Hochberg corrected is 1.0167. So this is larger than my critical value. And so, or my critical P, and so then that one doesn't count. And this is where that false discovery rate thing starts coming in right here. At comparison 3, we're still sneaking in underneath to what our critical value is, but as that goes up, then we go through, went from, our P value went from this one to 0.018 to 0.0175.
Okay.
Our correction was more than what Cop captured that. Not too. People kind of see sort of like what we did with that, sort of how we kind of broke that down. Okay. Other thing that we could have done, if we would have chosen a different thing and we weren't sort of wanting to go through Benjamin Hochberg this, if we were just kind of going through and wanting to test sort of differences here. Other thing we could have done is first started out with what we might find just like a simple effects ANOVA. And so just run a one-way ANOVA at time 1 and say, do we see differences at time 1 across things? And if that omnibus test didn't pop up, and say, nope, no differences there. So I'm not going to go through and pairwise to run a bunch of stuff. If I just run that initial omnibus test and I'm not seeing evidence for mean differences at time 1, cool. I'm not going to mess around with this. I'm just going to say nothing to see here, move on. Run that one-way simple effects ANOVA at post-treatment across my 3 groups. If I get an omnibus test that pops up, then I say, okay, and then maybe start to go through it and dig into what's going on with this stuff. Different way to approach it, kind of more efficient. In this situation, we're just kind of using that simple effects ANOVA as kind of the gatekeeper to say, do I sort of move forward with things? And what you might find is that we're not seeing any differences across groups in between groups comparison at pre-treatment, and we're not seeing any group differences in treatment group at post-treatment. Okay, and then we just say there's nothing to really sort of speak to necessarily about between groups treatments. Okay, so do we say that group doesn't matter then? No, because we know that group matters because we have that interaction. Okay, this is where it starts to become really, really, really important. Okay, we can see interaction effects with these models. They're saying, yes, group does matter in terms of the changing pattern of means across repeated assessments. But if I look at things that just a strictly between groups comparison, something might not pop up. Okay, that's because we have dramatic differences in power for that overall omnibus interaction than we do for any pairwise comparisons that we're running at the end. Okay, does that mean that group doesn't matter, is not sort of relevant? No, because the interaction tells us it is. What it's just saying is we're seeing differences in what I would suspect there is that probably what's driving that interaction is differences in the within groups change as opposed to just raw scores between. I know I should keep going back, and just because this is where this has come up sort of for me a number of times with looking at physiological stuff, right? Sometimes it means your physiological stuff, whether you look at heart rate, skin conductance, whatever, like between groups, it's all kind of sort of close and there's a lot of variability and stuff like that. It can take a lot to go through and sort of test the between stuff. So I might not see that anybody is necessarily starting at a different place or necessarily ending in a different place in terms of raw like means. But what I can see is that people are changing at different rates. I'm seeing differences in the within stuff, right? And that's where some of this stuff can start to sort of be useful to go through and take a look at. So if we look at this in terms of our write-up, okay, walking through this. Okay, so we say follow-up tests examine reductions in depressive scores from intake to 6 weeks separately within each treatment group. Additional exploratory analysis were conducted to assess differences across programs at both intake and 6-week assessment. Alpha inflation for exploratory tests was managed using the Benjamin Hochberg procedure. I'm just telling you what I'm doing. Like, this is my approach. There's not one right way to do it. I need to be very specific about how I'm following up with this interaction. And here that I'm telling you what's happening. Okay. Then we say evaluation of within subjects effects for large clinically significant reductions in depression for program 1 program 2 and program 3. Okay? Across the board, everybody's huge. Here's all my statistics. You can go through, take a look at those, right? Point estimates of average change in BDI2 and corresponding effect sizes along with relevant confidence bounds presented in figures 1 and 2. Those are my two sort of things that I presented there. Evaluation data points suggest potential for enhanced treatment response in program 2 and 3 relative to changes in program 1. Specifically, patients program 3 report an average reduction of over 20 points on the BDI, population estimates ranging from 18 to 22. Program 1, by contrast, had evidence 15-point reduction, changes between 13 and 17. Okay. Average reductions in program 2 comparable to those in program 3. Interval estimates within subject effect size suggest a similar pattern, although it's important to note lower bound estimates supported by these data indicate full standard deviation reduction for all 3 programs. Okay. So again, we're talking about minor differences here. Takeaway story, they're all sort of producing substantial reductions here, and just trying to go through. This is where I'm talking about all my within stuff, right? Talking about point estimates, talking about effect sizes, talking about practical effects in terms of like tying all this stuff in. Okay. Then we jump down to the between. Exploratory analysis between subject differences in intake in 6 weeks, consistent with potentially greater responding among patients in group 3. Group level contrast failed to provide strong support for differences when controlling for multiple comparisons or initial depression. However, at 6-week assessment, individual program 3 evidence lower BDI scores relative to patient program 1 and program 2, right? Both comparisons, depression scores for patients in program 3 were nearly 3 points lower. Those comparison programs, there's lower bound estimates, population differences supported by these tests were minimal. Confidence bounds for within subjects comparisons continue to suggest potential advantage for program 2 and 3. Okay. So what we're saying is that the between group differences that we're seeing, yeah, we're seeing a statistical advantage for program 3. But if you're working with the BDI at 3-point difference on the BDI, is probably not anything to like be so like super worked up about, right? So we're just kind of putting that in context and talking about kind of what we can take away from that. Okay. Overall results offer preliminary support for differences in program effectiveness across 6 weeks of inpatient care. As noted within subjects' effects indicated the potential for greater reduction in depression among patients program 2, 3, and 2 as compared to program 1. Between group contrasts are also consistent with incremental benefit of program 3. Results in the current project provide greater support for enhanced treatment response program 3 as compared to program 1, with promising but less compelling evidence for increased efficacy program 2. Right? So we're just trying to take this all together and tell a story, right? The story based on my omnibus test is the pattern of means across these 3 groups differ or across treatment differs across treatment group. This is my effort to try and explain kind of what might be happening with that. Questions? All right. So this was a pretty easy, straightforward situation with my ordered effects. Let's go back through and take a look at our vignettes. Our vignettes problem here. Okay. These are our ungrouped means. Okay. We found the same effects, right? We found that we have a main effect of repeated assessment and then a between by within interaction, right? Here we're going to have to think a little bit more carefully though on how we want to go through and try to tease this apart. Okay. So if we go down through and take a look, this is going to be our estimated marginal means here, right? Here are our between group means, right? So this is collapsing across vignette. What are average friendship ratings for my negative, for my benevolent, and for my interpersonal groups? Remember that we found an effect of that between right up here. And if I look at those means, I know exactly where that's happening. Like these two are identical functionally. This one is very close, but this is the odd man out and it's lower, right? Suggesting that my negative group is rating lower levels of friendship on average than the combination of the other two, right? But this effect is modified by individual vignette, okay? Here, we're saying, means across my individual vignettes collapsing across group, right? And it looks like 2 on average is lower than the other ones, right? 2 is my combat vignette. So Catherine is sort of military veteran off to war, come back. She's dodgy around some stuff. How willing are you to befriend Catherine? Well, we're seeing similar to these other ones, but statistically lower levels than what we would expect for car accident, sexual assault, and disaster here, right? But again, this is also moderated by group, right? So here we've got our group by our repeated assessment means. Anybody make heads or tail of that? I can't. So we're going through and looking at it, right? This is why it starts to become incredibly important to go through and plot this out. And if I do that, Jack, what's happening? What's driving this interaction?
It looks like negative is, it appears negative is lower than benevolent or interpersonal. And also that combat appears lower than theater 3.
Yeah, right. So what's going on here is it looks like, if I'm just looking at this, and this is super zoomed in, right? But if I pull this up, I'm getting parallel plots on all overall. My first 2 groups are responding pretty similarly, right? I mean, we kind of got a flat here and this goes down here. I don't know that I'm 0.2 differences sort of maybe driving everything. What's going on is we have our negative group that's just overall profile is lower, intercept is lower for these folks. And then they kind of floor out, at least relatively speaking, specifically for vets, right? What I'm thinking is probably on average, everybody is tending to report sort of support for vets as lower than the other 2, but is really pronounced in the in this negative group, at least relative to the other ones. Okay. So again, what we need to do is we need to think about how are we going to go through and test this. And again, wanting to think about some combination of a priori and planned comparisons with things, or a priori and exploratory stuff. Okay, let's say that for these analyses, a priori, my thought was that combat is going to be less than MVA, sexual assault, and disaster. Okay. That's sort of kind of what I figured, sort of in general. Okay. And probably sort of based on this, I'm sort of kind of seeing that. Let's say I kind of predicted that. Okay. Katie, what am I going to do? Tell me how I'm going to go through and test this for this interaction.
You're gonna go through and weight, like you're doing like the contrast, right?
Yeah.
So you have to go through and weight each of the different groups, so that the 3 groups are all the same, and then you're contrasting them against the combat group.
For who?
For all the classes.
For all 3 classes, yeah. So I'm going to have. So how many actual tests am I running with this?
1.
How many tests? If I'm running this for each class, how many tests is that?
Oh, each class 3.
3, right? So it gives me 3. Okay. So what I'm going to do is I'm going to say for each class. So my hypothesis is that readings of friendship are going to be lower for the combat vignette relative to the other 3. Okay. And so what I'm going to do is I'm going to go through and I'm going to split that file by group. And then what I'm going to do is I'm going to run a simple effects repeated measures ANOVA for each one of those. Okay. And what I'm going to do then after I run that simple effects repeated measures ANOVA That's gonna give me the sums of squares and stuff like that that I would use to run my individual contrasts for each one of these groups, okay? Consistent with the way that we had set it up previously, all right? Now, I could go through, and if I wanted to start pulling terms from my overall factorial ANOVA, it just starts to get dodgy given all the stuff that came up in this screening, and I don't want to do that because I'm not confident that those are appropriate to be using across sort of everything. And so what I can do to start reducing that is I'm just going to go through and I'm going to run a one-way repeated measures ANOVA split by file or split by group, and then it's going to give me 3 one-way ANOVAs. And then from the sort of the terms in there, I can start pulling through and set up my contrast for that. Okay. So this was my a priori. And then after I go through, and I've taken a look at this, right? And I'm like, oh, you know what I bet is going on is that my interpersonal and my benevolent groups are probably operating about the same. And it's the negative that's sort of really sort of the one that's different than everybody. Why do I think that? Because that's what the picture looks like is happening, right? Did I come up with that on my own before? No, I only saw it after I looked at that. And now all of a sudden, what I'm doing is I'm capitalizing on random patterns in the data, and that dramatically changes sort of this sort of per comparison error rate, things along those lines, right? And so what I'm going to go through and say is that for an exploratory set, because I came up with this after I had looked at my graph, I'm going to say that my negative group will be less than the combination of benevolent and interpersonal at each vignette. Okay. So we've got, this is, we're saying, this is what I went through and I wanted to compare, right? So this is a priori. So we're going to look at this per comparison error rates. This is exploratory. Okay. Charlotte, how many tests how many tests is it going to take to actually run that? If I'm looking at negative versus the combination of benevolent and interpersonal. 4, right? But here's where we have to start thinking carefully. How many actual comparisons did I make when I was developing this strategy? How many between group comparisons do I have for vignette 1? Catherine?
3.
3. And how many here? How many here? How many here? I just ran through 12 pairwise comparisons in my brain, and then like, oh, what I think is going on. Like, I didn't run 4. I ran 12, right? And so wanting to think about being cognizant about sort of what's actually happening as we're going through and running this. And so what I've got is I probably ought to be, if I'm being sort of good, is I probably ought to be correct in thinking about correcting for 12 comparisons here. Just because exploratorily, like that's what's going on, right? In terms of sort of teasing this apart. I took those 12 and reduced it down to 4, which is great because do I really need a statistical test to tell me if negative and benevolent are different at for the first vignette or at the second or the third, maybe the fourth, right? But no, I don't, right? So what I'm doing is I'm using contrast to sort of tell a more efficient story, but I got to be honest with myself. Is what I did is I actually ran through 12 possible pairwise comparisons. So I need to make sure that my correction is adequate for that. Okay. So we went through, if we go through and we take a look at sort of this full interaction, if we're just limiting ourselves to pairwise, we've got 30 valid comparisons that you could make out of that, right? And now obviously we're not going to compare this time point or that point to that point. That wouldn't make any sense of crossing factors and groups and things along those lines, right? There's 30 different pairwise comparisons you can pull out of that. Who wants to run 30 pairwise comparisons? no, ick, right? Because then I gotta go through like seriously, like, hey, William, guess what you get to do for this next set is tell me like crank out 30 pairwise comparisons, right? No, no one likes that, right? It's not gonna tell a good story, right? But what we gotta do is try and think about like how do we go through and manage sort of our approach here and sort of put things together, okay? Now, for this one, just to be kind of different, what I sort of went through is I set up, and what I'll do is I'll send you kind of an annotated, basically, I'll give you my notes for this one, okay? I could have done Benjamin Hochberg. Benjamin Hochberg would be the better way to do this, but just to show you a different way to go through and do this is I went through and sort of set up a modified Tukey with this, okay? And so we got through, if we were set on Tukey R equals 5, that's going to control for 10 comparisons. That's a little light. If I set R equal to 6, that's going to account for 15, right? Again, 5 times 4 divided by 2 gives me 10. 6 times 5 divided by 2 gives me 15, right? This is not enough. This is too much, okay? So what I'm going to do is I'm going to go through and I'm going to choose this. I'm going to go overcorrect, right? So just go through and make, okay, I'm going to be conservative with this. So I'm going to get set R equal to 6. The other thing we need to do is think about like, okay, what is our lowest degree of freedom across these individual comparisons, okay? If I'm going through and I'm looking at this, we've got an unbalanced design, right? So if you're going through and running your t-tests at each one of these, what's going to happen is depending on which sort of comparisons you're making, the degrees of freedom are going to jump around, right? Which starts to become problematic for a modified Tukey because which ones do I go through and I choose, right? But for the most conservative degree of freedom across my pairwise tests, this would be looking at a t-test between my negative group and my interpersonal group. I've got 44 people in my negative, interpersonal is 85. My lowest degree of freedom across those tests is going to be 127. So I'm going to use that for my modified Tukey. I'm just being super conservative here, okay? And so if I go through and I do this, and I calculate a Q critical, which is my Tukey test, with R equal to 6, with 127 degrees of freedom, my Q critical statistic is going to be 4.10, okay? And if I take that and I know that T is equal to Q over the square root of 2, what this gives me is a value of 2.90. Okay. So what I'm going to do with this is I'm going to say, what I'm going to do is I'm going to go through and run my tests. And if I get a T value that exceeds 2.90, I'm going to claim that evidence with my modified Tukey correction. Okay. If I got a T test that doesn't hit that, then I'm below. And this is a nice way to go through and just run through and set this up. Okay. Again, Benjamin Hochberg would be the better way to do it and the easier way to do it without sort of me just like kind of like this is like DIY alpha correction right here, right? But it's at least we're trying to go through and sort of manage some of this stuff. Okay. So what I'm going to do here is I am first going to go through and remember that okay, what we're going to do here is first go through and split this file by group, okay? And what I've got here is my one way repeated measures ANOVA for just my negative group, okay? And what I'm going to do here is I'm going to go through and use this, and I'll sort of post sort of my actual hand calculations here on use the values from my ANOVA table to run that repeated measures contrast here. Okay, so what I'm going to get is I'm going to get a value for my repeated for my contrast. Okay, Here it's gonna be, values or, excuse me. Weights here are gonna be MBA, combat, sexual assault, and disaster. Okay, again, here is my hypothesis. So what are the weights I'm gonna assign to this?
Comment's going to be negative or like,
Yeah.
like,
Yeah,
so like
and how many groups are in that side of the comparison?
3, or sorry, just 1. So
Yeah.
-1 and then everything else is 1/3.
1/3, 1/3, 1/3. Okay. Thing you gotta be careful with in SPSS, or well, I guess we're not doing this in SPSS, we're doing this by hand, right? So what we would do is we would take 1/3 multiplied by mean friendship rating for MBA, mean friendship rating for sexual assault, mean rating for disaster. That gonna give me my value, my contrast. Okay. And here that's gonna be value of contrast, it could be 0.690. Okay. This is the literal difference between in points across combat versus sort of my other 3. Okay. Then what I'm going to do is I'm going to go through and I'm going to use that to go through and calculate my test statistic using the formula I should have given in the slides. Okay. So here it's going to be the value of my contrast over the square root of 1/3 squared plus 1/3 squared plus 1/3 squared plus 1 squared plus or multiplied by my mean squared error, and I'm just going to pull that from my greenhouse geyser. Okay, don't worry about this. I'm going to sort of give you kind of my handwritten. You'll be able to go through and see kind of what this is looking at, right? So then I'm going to get my test statistic, and I've got sort of a test statistic that's sort of interpretable there, so to have evidence for an effect. From there, calculating my confidence bound is easy. I'm just going to take the value of my contrast, multiply it by my standard error that I get for this, and then multiply that by my critical value for my t-test, right? Going to get that, and then I can go through calculate sort of standard or effect size for this contrast. Okay. So we're going to do that for this within. Okay. And then my second one for my interpersonal class to do the same thing, run the same calculations. And oh, there's my negative. All right. So run this for my negative, my benevolent, and my interpersonal. SPSS won't do this for you. You have to crank it out by hand, but that's fine. You've got the formulas, and so long as you know where you're pulling stuff from, should go pretty quickly. Okay. Then what we're going to do is we're going to go down through, and I'm going to go through and calculate a one-way ANOVA across each one of these outcomes. Okay. The nice thing here is SPSS will do a very good job of going through and calculating this comparison individually for each one of those. I can just set those up in my output or in the output. And so here my weights are going to be -1 for my negative class plus 0.5 and 0.5 for my other two, because we're combining those two there. And here's homogeneity of variance, so we can go through and take a look at that. Here are my ANOVAs, right? And so here's what I'm talking about is thinking about this as my specific effects ANOVA. What I would probably do with this is just go through and Kitty, which one of these is the only one I should probably be interested in?
The combat.
The combat one, right? Here, my omnibus, so I'm just running a one-way ANOVA across my 3 groups at each for each vignette. This is the only one that's telling me that I have evidence for differences anywhere in this, right? What I would probably do to simplify this is just go through and say, for these other 3, there's nothing to see here. Like my omnibus test said that there were no differences, so I don't need to go through and like trudge through that. Yeah, these were all the same and stuff like that, because like my omnibus test, just like nothing to see here. I can move on to the stuff that's important. But here we are seeing differences with combat. And if I scroll down to look at my my stuff for my effect sizes here, or excuse me, my specific contrasts here for combat, I am sort of seeing that equal variance is assumed, right? So again, what I would need to do is go back up and look at my Levine's test for combat exposure. Do I see evidence of or violation of homogeneity of variance? Yeah, I do, right? So here I'm going to go through and be looking at equal variance is not assumed. So if I go equal variance is not assumed, look at my value of my contrast 0.75. My t-test is 2.77. Do I have evidence for that after I went through and corrected? No, it's not quite there, right? Now, recognizing that I was super conservative with sort of my approach, right? And that super conservative approach probably bit me in the ass right here, okay? But if this is what I've decided to do, it's kind of not fair to backtrack and be like, well, I'm going to go through and do this or something along those lines, right? So we want to be sort of thinking about sort of being careful there. The other thing too, if we go through and take a look now, well, we do have a couple other of these that are popping up as below 0.05. But these are both for equal variances assumed, and there was not equal variances assumed for anything. We also didn't find evidence for an omnibus effect for each one of these. So again, this starts to get into the place where you can get really kind of shady in terms of how you're going through and doing stuff, right? So you want to just be very thoughtful and planful about your approach before you start and saying, this is what I'm comfortable with, no matter what happens, and sort of proceeding with that. And there's nothing to say that you might not sort of say well, here's the thing, we didn't quite get it. But when we were looking at this, it looks like the differences between for assault versus my negative group versus the combination of my other two, looks like there might be something there. I wouldn't sort of put a whole lot of stock in it, but you can try and talk about it if you want to. Reviewers might smack you up and say you can't do that, but I mean, give it a shot, right? But just wanting to go through and make sure that you've got a plan here. And down here, we've got our effect sizes for individual effects that we're seeing. So again, with this, I don't know, I've got for this comparison, I've got an effect size of 0.64. That's a solid medium effect, right? I might advocate for that a little bit, right? Sort of recognize that I can't sort of claim evidence for it, but it might be something you want to look at, and it's kind of consistent with the overall pattern. Okay. Do people see how we went through and broke that down? Okay. So if we go back to and just close out with this, right? Kind of sort of pulling this up, right? So we're saying a priori comparisons were used to compare self-reported willingness to maintain friendship with hypothetical combat survivors relative to aggressive aggregate ratings of survivors of motor vehicle accident, sexual assault, natural disaster. Differences in willingness to maintain friendship in the negative versus the combination of benevolent interpersonal files were examined. For each vignette, instead of exploratory analysis, modified procedure was used to control for evaluation post-op comparisons. I got a footnote there because I'm going to have to explain what that is, what I did, what all that stuff is, right? Which is the drawback of this, is then you got to have to explain to people exactly what that is and why you did it. Okay. So I say a priori within group contrasts offer compelling reductions, support for reduction in willingness to maintain friendship for hypothetical survivors of military trauma versus other groups across negative, benevolent, and interpersonal profiles. Observed differences were greatest for participants in the negative profile, with data supporting reductions in larger population, 1/4 point to over a point. Corresponding within subjects effect was about a half standard deviation decreased willingness to maintain friendship. Participants benevolent in the negative groups also demonstrating incremental reductions in reporting willingness to maintain friendship or support, although within subjects effects were modest, lower bound estimates. Corresponding population differences indicating the possibility of trivial effects, right? So again, we're looking at for my benevolent, it's 1/10 of a point. It's 5/100ths of a point, just acknowledging that practically there might not be much there, right? Exploratory analysis between subjects, contrasts indicate a comparable rate of willingness to provide and maintain friendship in negative versus benevolent and interpersonal profiles for accidents, survivors of accidents, sexual assault, and natural disasters, right? So here, this is just for my omnibus, simple effects, Anova design or Anova effects, right? So I'm just saying I didn't even sort of jump into it because it's not worth looking at because I didn't see anything there. Okay. By contrast, willingness to maintain friendship with hypothetical survivors of combat trauma rated 0.7 to 5 points lower among participants in negative profile relative to combined benevolent and interpersonal groups. Observed differences exceed conventional benchmarks for medium effect. Data indicating a 0.65 standard deviation decrease in willingness to maintain friendship survivors of combat trauma. Okay, so just kind of pulling all that together. Results of the current study suggest that both beliefs about the consequence of trauma exposure, the type of exposure event influence willingness to maintain friendship with hypothetical survivors, whereas individuals in all profiles evidence reductions in support ratings for hypothetical survivors of combat versus non-combat trauma effects were particularly pronounced for respondents holding negative pejorative beliefs about consequences of exposure. Similarly, data failed to provide evidence for differences in support ratings across negative and the combined benevolent and interpersonal profile, except for with respect to hypothetical combat survivors. Omnibus says from the overall mixed factor Anova indicated a lower overall support among participants in the negative profile. The impact beliefs on willingness to maintain friendship may have the greatest effect for survivors of military trauma. Okay, what I did there at the end is I snuck in that sort of between, right? That overall one, right? To say overall Anova is saying that we're seeing lower effects for negative versus the other two, but based on our sort of follow-up, it looks like it's really just happening for the combat folks. Okay. So again, just trying to give you some ideas for how to go through. It's a lot of information, right? It's a lot of stuff to keep track of. For this problem set, I'm going to tell you what I want you to do. So if you're good, because otherwise, who knows, right? What could come out. So I'm going to tell you, but if you have questions about what's going on, come talk to me. Don't just like forge it alone and then sort of be off and way out in left field with things. Okay. But when you're running these types of analyses, they're really cool and really powerful. You just have to have a very, very good idea of what you're doing, why you're doing it. And so when you get these effects, how you might want to start to tease things apart. Conceptual summary here. And that is that. Okay. Big set. But you got sort of plenty of time to go through and work on it, right? Everybody's paired up again to remember just one set. I will get 3 sets. Okay, no one needs to do their own thing. But please work together as you're working through this stuff. So really sometimes it always with group work thing. Cindy's like, well, I did a good job, but Josh turned in something that was garbage. And so now I'm mad at Josh. But well, you can be mad at Josh. You also have looked at it before Josh turned it in and sort of gave it your thumbs up, thumbs down thing. So, but sort of go through, take a look. Let me know if you have questions. And that's that. Other thing too, the thing about like, so we had gone through and planned to try and sort of do like an end of semester thing and then beginning of semester thing. And then the whole goddamn world blew up. And so like I ended up sort of on the backside of it without a goddamn gallbladder. Finals week, next week, maybe because you're going to take off on Wednesday, maybe Monday or Tuesday, I'll go through and see if you all want to sort of go out, sort of maybe sort of go downtown, sort of catch a drink, something like that. I don't know. Is there a dive bar you want to go to? Anybody like go to the Ranger or something like that? Jack wants to go to the
yeah.
You have to wash your clothes after you get out of there, but you like taxidermy and bullet holes in mirrors, we might do that. All right. So yeah, we'll go through, set that up. You guys have been great. Thank you so much. Send out stuff for supervisors or evaluations. Make sure you fill those out. Make sure you fill out all your evaluations to go through, just so that we have good and fair ratings across sort of classes and things along those lines. But congratulations, a lot of work. First year is wild, but you all have been champions. So awesome. Thank you so much.
Thank you, Josh.
Thanks, Josh.
Also. Magic.